Welcome back to Nexus Tech. You know, every single day we're surrounded by this invisible shield. It's called encryption. It's the digital lock that protects everything from our emails to our bank accounts. But what if a new kind of key was being made? A key that can shatter that shield completely?
So let's just start with that thought. I mean, really think about it. What if your private messages, your company's secrets, even classified government data were suddenly wide open for anyone to see? This isn't science fiction, folks. This is the very real threat that's coming with the arrival of quantum computers.
So, to really get what's going on here, we have to understand the weapon. And this isn't just a faster laptop we're talking about. It's a completely different kind of machine, a new kind of danger.
The big difference really boils down to its fundamental building blocks. A classical computer, like the one you're watching this on right now, it works with bits. They're just simple switches that are either a 0 or a 1, off or on. But a quantum computer, it uses something way weirder, a qubit.
This crazy ability to be in multiple states at once is called superposition. Okay, think of it like this. It's like a spinning coin. While it's in the air, it's both heads and tails at the same time, right? Until it lands. And that is what gives quantum computers their incredible, mind-bending power. A power that is, unfortunately, perfectly suited to picking the lock on our entire digital world.
See, here's how that lock works. It's built on a clever mathematical trapdoor. It's incredibly easy for a computer to multiply two huge prime numbers together, but trying to take that result and work backward to find the original two primes, for a regular computer, that's almost impossible. That task would take, well,
Billions of years. Yeah, that's a pretty safe lock. I think we can all agree on that. But here's the terrifying part. A powerful quantum computer, using its unique ability to sift through all the possibilities at once, could solve that exact same problem in days, or maybe even hours. That sound you hear? That's every digital lock on Earth shattering all at once. Now you're probably thinking, okay, but these super powerful quantum computers don't exist yet, right? And you're correct, but the danger is already here because of a strategy that has security experts seriously on edge.
This strategy is called Harvest Now, Decrypt Later, and it's just as sinister as it sounds. Right now, as we speak, adversaries are actively capturing and storing massive amounts of our encrypted data.
All of that data, government secrets, corporate intelligence, your personal information, it's just sitting on a hard drive somewhere waiting for that quantum key to be built that will one day unlock it all. It's a ticking time bomb. But this is where our story takes a turn, because for every great threat, humanity engineers a defense. So what is this new armor? It's a whole new class of defense called Post-Quantum Cryptography, or PQC for short, and its mission is simple but absolutely crucial.
So here's the key. PQC doesn't rely on that prime number problem that we just talked about. Instead, it's built on entirely different kinds of complex math problems that are believed to be hard for all computers to solve, quantum included.
Now this is where things can get a little confusing. You might hear the term quantum cryptography and think it's the same as PQC. It's not. The easiest way to think of it is this. PQC is new software for today's computers that's designed to fight tomorrow's threat. Quantum cryptography is entirely new hardware that uses quantum physics itself to send secure messages. Both are going for a quantum-safe future, but they take very different paths to get there.
So, with the threat defined and the solution identified, the next logical step is a massive global undertaking. We have to upgrade, well, pretty much everything.
But this isn't some chaotic free-for-all upgrade. Oh no. This massive effort is being coordinated, and the organization leading the charge is a U.S. government agency you've probably heard of.
Now, NIST's approach wasn't to invent these new algorithms in some secret lab. Instead, they ran a global competition. It was an open, transparent process that started way back in 2016. They basically invited the world's best cryptographers to submit their best ideas and then try to break each other's work. And after years of absolutely rigorous testing, the first of these new standards were finalized in 2024. This is happening right now, which of course brings us back to the one big question that everyone always asks.
This is the billion-dollar question, right? And the honest answer is, nobody really knows for sure. The science is just incredibly complex. Building a stable quantum computer with enough power is a monumental engineering challenge.
So if it might be decades away, why the rush? Why is NIST finalizing these standards right now? Well, because of this one critical fact.
It takes a very, very long time to upgrade the entire planet's digital infrastructure. We're talking 10 to 20 years. We can't afford to wait until the threat is knocking at our door, because by then it will be far, far too late. The race has already started, which is why understanding it is so important.
You know, what we're witnessing isn't just a simple software patch. It's more like replacing the foundation of every single building in every city all at once. It's a fundamental shift in how we protect our entire digital world.
This transition is one of the biggest technological shifts happening right now, mostly behind the scenes. So to keep up with how this race and other technologies just like it are shaping our future, make sure you're subscribed to the Nexus Tech channel.
So let's just quickly recap the key takeaways from this whole global security upgrade. What do you really need to know? First, the quantum era is coming, and it threatens to shatter our current digital security. Second, that harvest now, decrypt later strategy makes this a problem for today, not some distant tomorrow. Third, post-quantum cryptography is the new shield we're building to defend ourselves. And finally, this isn't theoretical. The global migration to PQC is a massive, proactive effort that's already happening.
You know, this age-old race between code makers and code breakers has been going on for centuries. But this quantum leap, it changes the rules of the game entirely, which leaves us with a final, fascinating question to ponder. Thanks for watching. We'll see you next time on Nexus Tech.